Hi students, in this video I'll be going through the product rule of differentiation. Alright, so let's begin. Alright, so when do we apply the product rule? Okay, so we will apply the product rule if we are trying to differentiate an expression that is the product of two different terms. Okay, for example, over here, if let's say we are trying to differentiate with respect to x, two different terms, okay, one of them we call it u and the other one we call it v. Alright, so u and v are both expressions that are in terms of x, right? So how does the product rule work? Okay, so the mechanics of the product rule is actually very simple. Alright, so if u is one of the terms and v is the other term, so when we start to differentiate, okay, for the first part, the first half of the product rule, okay, so we'll divide the product rule into two halves. For the first half, you will not differentiate u, and then you will differentiate the term v, alright? Okay, then for the second half, you will not you will differentiate the term u, and then you will not differentiate the term v. Right, so let's use this following example over here, where we are trying to differentiate 3x minus 2 times 2x plus 5 with respect to x. Okay, so over here, let me call this term u, and let me call this one v. Right, so let's apply what we have just discussed. Right, so now we are differentiating 3x minus 2 and then the product with 2x plus 5, right? Okay, so according to what we have discussed earlier, okay, we will differentiate u. So now u is this and v is this. So we'll leave u untouched. Okay, then we will differentiate v. Alright, so differentiating 2x plus 5 will just simply give us a 2, right? Okay, so that's how we get the 2. Okay, so the 2 comes from differentiating 2x plus 5, which is actually 2, okay? Okay, so leave u untouched, differentiate v, plus, okay, now we will differentiate u. Okay, so if we differentiate u, okay, u is 3x minus 2, right? Okay, if you differentiate u, you will get 3. So now you have your 3, and then you will leave the v untouched, alright? So this will be 2x plus 5. Right, so all we need to do now is just to expand this out and then simplify, and we will be able to get the derivative of 3x minus 2 times 2x plus 5. Okay, so over here we have 6x minus 4 plus 6x plus 15, right? So we will get 12x plus 11, right? So this will be the answer. All right, let's try to verify this differentiation based on what we have learned previously, right? So let's say now we are trying to differentiate 3x minus 2, 2x plus 5. Okay, let's expand this one out first. If we have to expand this one out, we will get 6x squared plus 15x minus 4x minus 10, right? So if we simplify this, we'll get 6x squared plus 11x. Right, so remember we were trying to differentiate this one using the product rule. Okay, let's see if it will work if we don't use the product rule. Okay, let's see if we get the same answer. Okay, so we have already expressed this one in this form. So if I want to differentiate 3x minus 2 times 2x plus 5 is the same as differentiating 6x squared plus, okay, there's a minus 10 here, plus 11x minus 10, right? Okay, it's the same as differentiating this. Right, so differentiate 6x squared, bring the power in front, 6 times 2, you get 12, reduce the power by 1. Okay, differentiate 11x, power 1 goes in front, plus 11, reduce the power by 1, become x to the power of 0, so you just get this. Right, so you can see that the two answers over here and here are the same. Alright, so this means that what we have learned regarding the product rule actually works, right? Okay, let's now proceed to do some practice questions with regards to the product rule. Right, so just like any other mathematical skill, the more you practice, the better you'll get and the more confident you'll get. Alright, so for each question, you may wish to pause the video, try the question on your own first before proceeding. Right, let's practice. Okay, so now we are asked to differentiate 2x times 1 minus 5x squared. Okay, so as you will see later for the product rule, sometimes you will need to apply the chain rule inside the product rule. Alright, so if you have forgotten about how to do the chain rule, then please watch the video that is before this, right? Okay, so now we want to differentiate 2x times 1 minus 5x squared, right? So differentiate over here, 2x, 1 minus 5x squared. Okay, so same thing, remember, if this is u, this is v. Okay, so we don't differentiate u yet. Okay, then we differentiate v first. Okay, so if we differentiate 1 minus 5x whole thing squared, the power comes down. Power reduces by 1. Okay, so over here we are using the chain rule. We need to differentiate inside the bracket. Okay, differentiate inside the bracket, you will get negative 5. Okay, so we are done with the first half. So product rule is always a plus. Okay, next one, now we will differentiate the u first, the first term. Okay, so differentiating 2x will give us a 2. Okay, then the v remains untouched for the second half of the product rule. Okay, so over here we will just do some tidying up. Okay, so if you simplify here, you will get negative 20x and 1 minus 5x plus 2, 1 minus 5x squared. Okay, so over here for the product rule, usually for the second part, we need to do some factorization. So let's take out some common factor. Okay, there's a 20 here, there's a 2 here, so 2 is a common factor, so we'll take out 2. Okay, there's a 1 minus 5x, there's a 1 minus 5x squared here. Right, so whenever you have a common factor, you always take out the smaller power. So we'll take out 1 minus 5x. Right, so we are left with this. Okay, then all you need to do is to ask yourself, okay, what you multiply, okay, what is going to be over here? When you multiply by 2 times 1 minus 5x, will give you back this whole expression. Remember, there's a negative sign in front. Okay, so there's a 2 here, so this means that here we'll have a negative 10. Negative 10 times 2 will give me the negative 20. Right, then there's another x that is missing, alright, so negative 10x. Right, so just like this. Okay, let's then do the same thing over here. Okay, now you ask yourself instead, what multiplied by 2 times 1 minus 5x will give me back this whole expression. Okay, 2 has been taken out, 1 minus 5x, 1 of it has been taken out, so this means that what is remaining will just be 1 more 1 minus 5x. Right, so just have to tidy up the bracket. Okay, so you will get 1 minus 15x. Right, so this will be the answer. Right, so I hope you are following well so far. Alright, let's take a look at the next question. Alright, so let's apply the product rule again. Okay, so we want to pause the video, try the question on own first before proceeding. Right. Okay, so we will not differentiate the first term, which is 1 minus 2x. So after you do many questions, you will become very familiar with it. Okay, let's differentiate this over here, this v, okay, this u, right? Okay, so we bring the 4 in front, so we get x squared plus 3 cube. Okay, then remember chain rule, we'll differentiate inside, you'll get 2x now. Okay, so we'll multiply here. Plus, okay, now we will differentiate the u. Okay, differentiating u will give you negative 2. Okay, then x squared plus 3 to the power 4. Right, let's tidy up a bit first. 4 times 2x will give me 8x. X squared plus 3 cubed. Okay, then over here minus 2, x squared plus 3 to the power 4. Right, so once again, there's a 2 common factors, so we'll take it out. Right, the other common factor will be x squared plus 3 cubed, right? This is the power 4. We take out the smaller power, x squared plus 3 cubed, right? Okay, so there's a minus sign here, so I'll put minus this time, right? How did the minus come about? Plus times minus, you get minus. Right, so we need an 8x, so there will be a 4 here. X is still not there, and then the 1 minus 2x, okay? Right, then inside the bracket, 2 has been taken out, x squared plus 3 cubed has been taken out, so that means there's 1 more x squared plus 3, right? Okay, so from here, we will get squared plus 3 cubed. Okay, let's simplify a bit. 4x minus 8x squared minus x squared minus 3. Okay, so if you kind of do at once, then just perform an intermediate step to avoid making a mistake, right? Okay, then just simplify a bit. So negative 8x squared minus 8x squared, you get negative 9x squared plus 4x minus 3, right? So this will be the answer. Okay, so the thing about product rule is practice the factorizing part. Okay, this part is important. Okay, the factorizing. Okay, after you understand the mechanics well of how to perform the product rule, then the next thing to master will be this factorizing part. Alright, but it's actually not too difficult if you understand how it works. Okay, let's look at some more challenging questions. Okay, so over here we are asked to find the derivative with differentiate each of the following functions. Okay, let's prepare this in a form that is suitable for differentiation. So this one we'll just change to power half. So square root is power half. Okay, now we can perform the differentiation. Okay, so if they give you y equals to an equation like this, then it's dy dx. Okay, so once again we won't differentiate the first term, we'll differentiate the second term. Okay, so the half goes in front, 2x minus 1, then reduce the power by 1, so become minus half. Differentiate inside the bracket. So remember, we always applying the chain rule inside the product rule. Okay, now we'll differentiate the first term, which is this one. It will just give us a 3. Okay, then 2x minus 1 to the power of half. Right, let's tidy up the left side first. Okay, so half times 2 will just become 1. So in other words, for the first half, we'll just be left with this. Right, so what are the common factors? So the common factor will be this 2x minus 1. Okay, on the first half of the product rule, okay, you have power negative half. The second half, you have power half. Okay, so always take out the smaller power. So you take out 2x minus 1 to the power of negative half. Okay, so over here it's a plus. Okay, so what times this will give me this one? Okay, so it's quite obvious there's a 3x minus 1. Okay, so this part you may have to think a bit, the second half. Okay, but once you get familiar, it will be very easy. So basically, what times 2x minus 1 to the power of negative half will give me this 3 times 2x minus 1 to the power of half. So the 3 is obviously there. Okay, so let's try to ask ourselves this question. So basically, what we are trying to find is this one times what will give me 2x minus 1 to the power of half. Okay, so let's change this into a different form. Okay, let's say we let a okay, let a be this whole 2x minus 1. So here will be a to the power of negative half times a to the power of what will give me a to the power of half. Okay, so according to a law of indices, okay, when we multiply add the power, right? So in other words, we are just asking ourselves negative half plus what will give me half. Okay, you will see that it's going to be a to the power of 1. Okay, because same base, you add the power. Okay, so in other words, what we need is a to the power of 1, which is a is now 2x minus 1, right? So what we need here will be 2x minus 1. Okay, so one thing to note is that for this kind of question, right, okay, on the product rule, after you factorize, it should be very easy to simplify the terms inside here. So inside here, there shouldn't be any weird powers like power half or power negative half or even power cube or things like this. Okay, it should be relatively easy to simplify one. So if after you factorize and inside it's not easy to factorize, then do check your factorization, right? Okay, so over here we have this. Okay, let's simplify inside the bracket. 3x plus 6x, so you will get actually a 9x. Negative 1 minus 3, so we'll get a negative 4. Okay, so this is what we are left with. Okay, so let's change it to the positive index. Okay, so you'll get 2x minus 1 to the power of half. Okay, then let's return it to the square root form, right? Okay, so square root 2x minus 1. Right, so this will be the answer already, right? Okay, so let's try a couple more questions. Okay, then hopefully you will get a hang of it, right? Okay, so the next question we want to do is this. Okay, let's prepare for put in a form suitable for differentiation. Okay, so power half. Okay, let's differentiate now. Okay, so first term, okay, don't differentiate yet. Okay, then differentiate this second term, you get half x squared plus 1. Reduce the power by 1. Differentiate inside the bracket, you'll get a 2x and multiply it here. Right, the next part will be to differentiate the first term, the x squared, so you get 2x. And then the second term, okay, don't touch. Okay, let's tidy this first half first. So half times 2x, you'll just get x. X times x, you'll get x cubed. Okay, so actually we're just left with this. That's 2x, x squared plus 1 to the power of half. Right, so what are the common factors? Looks like we just have an x, okay, as a common factor. So let's pick it out. Okay, so okay, the other common factor will be this, of course, okay. So we always take out the smaller power, x squared plus 1 to the power of negative half. Okay, so what we are left here will be x squared plus 2 and x squared plus 1, right? So power 1 times power negative half, once again, will give me the power half, right? So once again, after you factorize, inside the bracket, it should be relatively easy to simplify. Okay, so you'll get 3x squared plus 1, right? 3x squared plus 2, sorry. Okay, 2 times 1, okay, so 3x squared plus 2. Okay, so let's put it. Okay, this one goes below again to make it positive index, and let's finally just put it in the square root form. Okay, so you get x 3x squared plus 2 over square root x squared plus 1. Right, so not too difficult. Okay, so go and practice multiple questions on this, and you will definitely be able to get the hang of it rather quickly. Right. Right, for the last question, let's try this application question. So over here, they want us to find the gradient of the curve, y equals to 2x times 4x minus 1 squared, x equals to 1. Okay, so remember when you do dy dx, when you find the derivative, what you're actually finding is the gradient function. Okay, once you have the dy dx, the gradient function, you just sub any value of x inside, and you will be able to find the gradient of the tangent of the curve, right, at that particular x value that you sub in. Right, so over here, okay, let's first find the gradient function by differentiating. Okay, so this one requires the product rule because it's the product of 2x and 4x minus 1 squared. Right, so don't differentiate the first term. Okay, differentiate using the chain rule. Power reduced by 1. Okay, so then differentiate inside, you get 4 and you multiply here, plus. Okay, now differentiate the 2x, you'll get 2 and 4x minus 1 squared. Right, let's tidy up first. 2 times 2 times 4, get 16x. 4x minus 1 plus 2, 4x minus 1 squared. Right, we'll take out the common factor 2 and the 4x minus 1. Okay, so inside we will just be left with 8x, right, plus 2 taken out and then 4x minus 1. Right, so you'll get this. Okay, over here you'll get a 12x minus 1. Right, so we want to find the gradient of the curve at x equals to 1. So we're going to sub x equals to 1 inside the dy dx. When x equals to 1, dy dx equals to 2. Okay, 4. Replace the x with 1. Okay, so over here you'll get 2. Over here you'll get 3. Over here you will get 12 minus 11. Right, so you'll get 66. Right, so 66 is a very big gradient. Okay, so let's take a look at the curve. Okay, so over here I've actually already used Desmos to draw the curve. Right, so you can see that at this dotted point, right, is x equals to 1. Okay, remember we sub in x equals to 1 into the dy dx, right? Okay, so basically what we're trying to do when we sub x equals 1 to get the 66, right, it means this is the gradient of this red color tangent. Okay, the gradient of this red color tangent. Okay, that's why the answer is so big, because as you can see here, the tangent is very steep. Okay, so the more closer you are to a vertical, the greater the number for the gradient of the tangent. Right, so that's the significance of your answer. What you are finding of dy dx when you sub x equals to 1, you are basically finding when you draw a gradient to the curve, right, at the point x equals to 1, what you are doing is you are finding the gradient. When you draw a tangent to the curve at the point x equals 1, what you are doing when you sub x equals to 1 into the dy dx is to find the gradient of that tangent. Right, so this is what we are trying to do. Okay, so I hope this video has allowed you to be more confident with the product rule. Okay, so actually it's not that difficult. Okay, so do try the homework questions and see if you can do it or not. Right.